this is the solution for the missing mass problem. At least it could be. So I guess a good place to start is where this mass is coming from. And in the Newtonian way of thinking, it's easy to see how we think that there's another type of matter that is resulting in this extra gravity. I don't believe that that's correct. And I believe that if that was correct, we would have evidence to support the existence of it. So then the question is, where would this extra mass be coming from? So I reflect to Einstein's work. And if energy is conserved, then if the velocity of light is changed, photons would have to adapt mass in order to have the same energy. So therefore, the change in mass would be inversely proportional to the square root of the velocity lost, or the change in velocity. And why would this be happening? Well, if a photon is accelerating towards a planet, or not accelerating, sorry, if a photon is heading towards any mass, and it starts to experience the gravitational force of that mass, even if the initial mass of a photon is next to massless, it would still be experiencing a want to speed up due to the gravity. Now, if light can't exceed its own speed, then it won't. But then it passes that mass, and what happens on the backside? Now it starts experiencing a negative acceleration. Now it slows down. Now that the amount that it slows down may be very, very small. But if we look at the amount of light the amount of photons going by a mass, then the amount of photons going, it would be like a water flowing around a rock in a river, where the water closer to the rock kind of gets sucked in, but it still flows, and it's still constantly changing, but the water, as it gets closer, starts experiencing a reduced velocity, and it quickly breaks free of that and goes back into the stream, back into its normal speed, or velocity, sorry. So this is kind of a little drawing to kind of depict that, where you have photons coming in and they kind of drag, but they keep going, and they spread back out. So if this is true, then the difference between the centripetal force of masses and the gravitational force would be because we're not including the mass that's added from the photons that have the mass induced on them, and all of them around any given mass, which would become infinite and infinitely small as you go out, but it would still be present. So I've depicted this as setting the gravitational force equal to the centripetal force of two masses. I started with the Earth and the Moon, and I've checked this with several other masses, and it seems to be consistent. That if you multiply each, and if the ratio of the mass induced on all the photons is proportional to the initial mass itself, so if the relationship between the mass induced is the same for the Moon as it would be for the Earth, then you can represent the concept as something you can use, you can use the constant to multiply by each mass in order to get a full depiction of the mass involved. So now it's not just the mass of the planet, it's the mass of the planet plus the additional mass from all the photons. So this would be the constant that you use. So I call it the missing mass constant. And that's because the missing mass problem eventually became the dark matter problem. I felt the missing mass problem was a much better name, and it's highly likely that the reason it hasn't been solved is because the name got changed to a dark matter problem, and then we started looking for a matter that doesn't exist, which may not exist. I can't say indefinitely that it doesn't. This could all be completely wrong. I mean, being that I'm just, some guy with a whiteboard, and there's incredibly intelligent people working on these problems, it's probably wrong, but I think it's still worth looking into. So this would be the constant that you could multiply any mass by, and that would give you the actual mass, including the mass induced on all the photons around it, which would get infinitely small the farther you got out, to a point where it's negligible. That's why I only brought this to 8 decimal places. I feel that that's a good depiction of the constant. If you wanted to get further than that depiction, I would need much more than a whiteboard and insanity. So hopefully this helps. Thank you.